Okay, in lesson 8.3, you're going to be planning an aquarium. So you're going to apply a lot of the area and volume concepts that you learned throughout this year so far into what you're going to do here. So let's get going with it. So to start off here, let's just talk a little bit again about the division of decimals. Now, when you're looking at this, I think it's one thing really important for you to understand is like what multiples, factors, all those sorts of things are, because it can help you get this estimation probably pretty quick. So if you know that 20.75 divided by 8.3, you know you're going to have something. I know that 20 and then this will be close to 10. And I'm making it these two because in division then, I know that it's going to make this problem a lot easier to solve. I wouldn't make this 21 and this 8 because 8 does not go into 21. But I know 20 and 10 work together. So when I do that, I know that this is going to be close to 2, so the decimal would end up being right around in there. Okay, so when you would divide here, this 40 divided by a half, you got to remember when you're dividing by something, you're actually multiplying by the reciprocal. So thinking about this, you're dividing 40 into halves. So you're going to get something that's actually a lot bigger in this case, because 40 divided by 1/2 is the same thing as 40 over 1 times 2 over 1. That would be 80 over 1, which is 80. So you know that your answer then is going to be 71 would be close anyways, because we rounded this up. So that's what's going to make that a little bit different. So the same thing would end up happening in this problem right here, that you're going to get something that's a lot bigger because you're dividing by something that's different. So let's just make that estimation, I guess, so to say. In this case, you might end up saying that that's 20. And you could keep this the way that it is. So you would say that that's 5/100ths. So then you would have to change this 20 over 1 to actually times 100 over 5. 2 times 1 is 2. Add 3 zeros over 5. Well, it seems like it's a pretty laborious process, but I think it'll help you out a little bit anyways. 5 goes into 20 4 times, add 2 zeros. So you know your answer is probably going to be somewhere right in there. 352 would be the estimation. You know it's going to be close to 400. But that's just, again, a quick overview of what you're going to be doing, what that is, dividing by decimals. So what you're going to do here is solve math problems 1 and 2 on journal page 283. So you're going to go to 1 and 2 on page 283, and you're going to solve those problems. They're pretty simple volume problems. You're just going to have some fractions that are involved with it. If you remember, volume, area equals length times width. Volume equals length times width, and then also times the height. Okay, some people call this, there's a big B, sometimes they call it the area of the base. That's basically just length times width. So you're going to do those two things first. Start on that, and then go ahead and pause the video, work on those two problems, and then come back and we'll talk about that a little bit, and then we'll talk about how this is going to apply to some of what you're going to be doing here. So go ahead, hit pause, work on those two problems, and come back to the video then. So when you look at that, it's asking the Glenn is buying a fish tank for his goldfish. He learned that a 1-inch goldfish needs at least 230 cubic inches of water to be healthy. Swimmy is his name, is 1 inch long. Find the volume in cubic inches of each fish tank. So as you're looking at these things, you're just multiplying. It's all in inches, so you're multiplying the three problems together. We'll talk about this a little bit as we go here. And then the second question is, which fish tank should Glenn buy for Swimmy? So when you look at this, which one did you decide? Some of you may have chosen, this says fish tank 2, because it has a greater volume and it's more room to swim. But 200 tell students, it says here that 230 cubic inches per inch of fish length is a common guideline for choosing an aquarium. So when you look at those two things, you have a 4 by 8.5 by 7, and then you also have a 4 by 5.5 by 12. Okay, so obviously the one has more cubic area than the other one.
of this, if a 1-inch fish needs 230 cubic inches of water, how many cubic inches of water does a 3-inch fish need? A 3-inch fish need. So if you think about that, 230 times 3, he needs 690 cubic inches. Well, how could you decide what size fish tank to buy if you had 3 2-inch fish and 3 4-inch fish? So here's how you would go about a problem like that. So the total length of all the fish is 3 times 2 plus 3 times 4. That's 18 inches of when you add all of your fishes together. If each inch of fish requires 230, you have your 18 times 230, you need a 4,140 cubic inch tank in order to fit all those. Okay? So it ends up being quite a bit. You need a pretty big tank then for those fish to be able to swim and kind of be safe. Your assignment kind of the rest of the play is to start determining those things. Because number 3